All right, let's turn our attention to these spine switches and go ahead and get those configurations in place. So I said that I would create an interface loopback 201, and on that interface I would give it a unique IP address, and we said that it would be 10.1.200.201/32. I also said that it would need to be running the routing process, so we'll say IP router OSPF underlay infra area 0000, and IP PIM sparse mode is a requirement as well. Next thing I'm going to do is I'm going to create the shared interface. Interface loopback 200, IP address 10.1.200.200/32. We'll advertise it in the routing process. We will enable IP PIM sparse mode. And just for the sake of clarifying, let's go to interface loopback 201 and let's use a description. And what we're going to say is this is going to be the Anycast unique IP. Let's say Anycast-RP set ID. And then let's go to loopback 200 and we'll simply say description. We'll say shared Anycast IP, just for clarity's sake. So with that being done, what I'm going to do now is I'm going to go into the process, show IP OSPF interface brief, and let's see if it is indeed running OSPF. It is. There are loopback interfaces, and show IP PIM interface brief should give me the fact that I'm now running on 5 interfaces, which I am. So now what we'll do is we'll do the configuration on spine 202, config T. We'll say interface LO 202, and we'll say description. And I'll just go ahead and steal the description off this one so I don't have to constantly keep making reference to it. So this is going to be the Anycast-RP set ID. IP address 10.1.200.202/32. IP PIM sparse mode, and IP router OSPF underlay infra area 0, interface LO 200, and this is going to be the interface that has the shared address. So I'll come over here, just paste that in, shared Anycast IP address, and we'll say 10.1.200.200/32. We'll go ahead and enable PIM and run the routing process. End. So with this being done, show IP PIM interface brief, and I see I'm now running on 5 interfaces. Let's see who's participating in this cluster that we built. So I'll say show IP PIM RP, and we'll see here in the config show IP PIM RP, I don't see anything. And let's say show IP PIM RP. And right now I don't see anything, but the point is I'm missing some configuration. So what we did is we just configured those interfaces. Show run interface LO 201 and show interface LO 202, 200. And then 202 and 200 on the other device, but we haven't told the spines how to use these configuration or these interfaces. So that's what I'm going to do next. And I'm going to do that by typing IP PIM, and what we're going to do is we're going to say Anycast-RP, and we're going to say 10.1.200.200, and I'm going to say that my interface 10.1.200.201 is part of that group, and I'm also going to say that the address of 10.1.200.202 is part of that group. So now if I look at this and show IP PIM RP, we should actually see that we have the 2 Anycast-RP members that are representing the group I'm sorry, that are representing the address of 10.1.200.200, and we can see that 201 and 202 are participating, and this little asterisk tells me that that's me. So it tells me that that is my address. So, and I know that because I'm on spine 201. Let's go ahead and do the same configuration on the other device. So I'll just grab this and paste it onto 4, so config T first and then paste. And now what we're going to do is we'll say show IP PIM RP, and we see that we have the members. So this is our Anycast-RP set, and it's comprised of spine 201 and spine 202. Now the only thing that's missing is that now, based on what we know about our multicast environment, every device in our infrastructure has to learn the identity of the rendezvous point. So for simplicity's sake, I'm just going to manually assign that. So I'm going to say config T IP PIM RP address is going to be 10.1.200.200, and I'm going to go ahead and do this for the entire multicast range. And all we'll do is we'll just paste this in on each of our devices, and then what we want to do is see if everybody agrees. So config T, paste, config T, paste, and config. I keep going terminal. You don't have to do terminal in XOS, but I do a lot of iOS stuff anymore. So let's see if everybody agrees. So I'll say in and show IP PIM RP, and we see that indeed we are using the rendezvous point 10.1.200.200. We don't know anything about the Anycast set. All we know is how to get to the rendezvous point. Same thing on the second leaf. Show IP PIM RP. Have no idea of how to get to the, or I have the RP, but I have no idea of the set. If I do the same commands on the spines, we'll see the set and the RP. Show IP PIM RP. So we're using 200, of which I am 200. That's what that little asterisk means. But also over here, interestingly enough, show IP PIM RP. Says I'm 200. So we are functioning as Anycast devices because we're both part of this set. Now we'll come back to this and we'll revisit it once we get our configuration operational. And in order to be able to do that, we need to turn our attention to the creation of these NVE interfaces. That's what we're going to do in the subsequent video, where again we're going to talk about it from a theoretical perspective when it comes to creating this logical interface that's actually going to be the interface that we're going to use to create the concept of the VXLAN tunneling endpoint. I'm Terry Vinson. I'll see you guys in the next video, and until then, I'd like to thank you for learning data center with me.